Alright, so in this video we're going to be talking about matter and its properties. This is a pretty fundamental basic topic when it comes to chemistry as a whole, and this is the first topic I covered in my general chem course. So firstly, what is matter? Matter, anything that has mass and occupies space. And that can be literally anything, so like air, yourself, like a table. It can literally be anything. Everything is matter. And the study of this matter is what we call chemistry. Study of matter. And what we mean by study of matter, we mean its physical and chemical properties and the changes it undergoes. Alright. Okay, now let's just talk a little more about matter. We said that it's literally everything. So for us to help classify it better and make studying it a bit easier, we use chemistry. And as such, chemistry also works based on, it's the study of the characteristics of matter. And the characteristics are defined by classifications. Now the classifications that we commonly refer to are one being state, that is your solid, liquid, or gas, and secondly it is your composition. So that would be a pure substance, pure substance, or it would be mixtures. Alright, let's quickly go over each of these classifications. First let's talk about state. So states, so when it comes to states, we have our solid, and if we were to describe a solid, we would say that the particles are very close together. We would say defined shape and volume, and then we would also say that the particles vibrate in place. All right, and if we had an example of this, this is just any container or the interior of anything. With solids, you're going to see that the particles are like super close together. They're like this, and it keeps going on this way. So they're really close together and they just vibrate in place. All right, and as such, they also have a defined shape and volume. The second one is liquid. When it comes to liquids, the particles are further apart, relative to solids. They're not super far apart, but they're further apart. We say particles slide over each other, and we say defined volume, but no defined shape. Another thing that can be mentioned is that liquids take the shape of the container they are placed in. So when you put water in like a tub, it would be the same as, it would just assume the shape of the tub. If you put it in a bottle, it would take the shape of the water of the bottle, so on and so forth, you know. And if we were to again talk about the arrangement of the particles, it would be a little further apart, but not super far apart, like about how much they have some motion. Yeah, about something like that. And then thirdly, we have gases. And when it comes to gases, it's pretty much just the opposite of solids. So the particles are far apart from each other. They have no defined shape or no defined shape, doesn't have a defined shape or volume. And then the particles in gases are, well, they're just like all over the place, aren't they? They just hate each other. They're as far apart as can be. So that's the first type of classification. And the other type of classification is composition. So let's talk about that really quickly. Composition. So when it comes to composition, you have your pure substances first. So I'm going to write it like this, pure substances. And under that, you have your, firstly, you have elements. All right. So elements are the most basic forms of matter. So there's like a singular thing, right? They're really basic. And examples of this, they just make up everything. Carbon, oxygen, basically everything on the periodic table is an element, right? As we know, like nitrogen, like the world is yours, endless, elements out there. Well, not endless, like whatever's in the periodic table, but quite a lot. Anyways, and your other one would be your compounds, your other pure substance. And so under that, well, if we were to explain what that is, it would be two or more elements combined together. Now this is really important to mention in a chemical reaction. I'm going to highlight that just to give emphasis. So they're chemically combined. We'll come back to that in a second. And then so we finished pure substances. Pure substances are these two. Like, let me just give some examples of compounds. You can say NaCl, which is sodium chloride, so that's table salt, And then you can also say like HCl, hydrochloric acid, the stuff that helps digest proteins in your stomach. And then like many examples, like endless. So yeah. And then your other composition is mixtures. So mixtures are, well, if we were to explain what it is, it's two or more. The main thing here is that it's substances. Over here, you notice how we said elements. Over here, it's substances, so it can be literally anything combined together by, this is also really important, physical means. And we'll get back to what physical and chemical means and reactions and properties mean in just a second. And so under this, we have two examples of this. We have homogeneous mixtures, and we have heterogeneous. And the name's going to give it away here, but we'll just explain what each of it is. So over here, homo means same, and hetero means different. I'm sure we know that. So by that, you can say that uniform composition. So the composition is the same throughout. And so examples of this would be air. It would be like if you had dissolved like salt and water. Salt and dissolved water. Basically, the way I think about it is if I put my hand through it and there's just one sensation, that's uniform composition. And that's a homogeneous mixture as such. Now, obviously, you can't really apply that in every case, but just think about it like that. I think it helps. And then heterogeneous, which we said is different. It means different, so different composition. Again, the example, the way of understanding, I would say, is the same. However, for this, of course, it means different composition. So examples of this would be like concrete, for example. I think pretty straightforward there. Oil and water is something that comes to mind as well. So, when you put your hand through oil and water, it's two different things because oil is dissolved in water, and same with concrete. Of course, don't put your hand in concrete, but just the idea, and even it can be literally anything. If you had like salt in water, even that's a heterogeneous mixture because like when I put my hand in that, I would feel two different things there, right? So it's that's how I think of it. You can think of it however you want, but I think that helps. I think, but yeah. Anyways, so we've gone through classifications. Okay, let's now quickly move on to physical and chemical properties. We spoke about this previously over here and over here again, but let's actually give definition to it. So we mentioned at the very start even physical, chemical, and then the changes that it undergoes. So let's start with physical. Let's do physical. Let's just name it physical, and let's do this. And okay, so physical properties are. So firstly, let's do the physical properties, right? So physical properties. So what are these properties? What do they mean? So physical property is something that can be observed. So property that can be observed or measured without changing the composition of matter. Alright, so this is like something which like you can observe it without having to change the fundamental way that the matter exists in. Okay, and so examples of this would be like color, for example. We can just observe that. You don't have to change anything for that. And then another example could be length, I guess. Density, pressure, mass, right? And then, yeah, so anything that can be observed without having to change the composition, all right? And then let's talk about physical changes now. So when we talk about physical changes, it is producing a difference in appearance without affecting the composition. All right, and now examples of this would be, well, you could say, let's say crushing a can, for example. Let's say shredding paper. Let's talk a little more scientific here as well. We could say boiling water and melting water as well. Melting ice, sorry. Boiling and melting water / ice. So you see that's like a reversible thing, right? And it doesn't really affect the composition because water is H2O and nothing's really happening to that H2O or anything like that. It's just the physical aspect of it that's changing, but the composition remains the same. So I hope that helps you understand that a little better. And then we have to talk about one more thing when it comes to physical properties and physical changes, which is intensive and extensive properties. So that's a kind of physical property, actually. I should have mentioned it a bit before, but it's okay. Let's just talk about it now. Let's actually kind of like signpost to that. Okay, so let's start with intensive property. Keyword in, so it means independent of amount or quantity of matter present. All right, so it's basically a property which is independent of how much matter is present, so it doesn't change basically, right? Because it's independent. And you know, they both have in, so that's kind of how I remember them. And so like examples of this could be color. You know, doesn't matter how much of something is present, color is going to be the same. The melting and boiling point. Another one is temperature. Now you may be wondering, like, oh, what like temperature does change? Well, it doesn't, because imagine it this way: if you have like a gallon of water, which is 20 degrees, like it's at 20 degrees Celsius, and you have a cup of water at 20 degrees Celsius, right? And then you put them both together, the temperature is still going to be 20 degrees Celsius. It doesn't change depending on how much you have, right? So that's how you could think of that. And so yeah, that's intensive property, and those are some examples. Let's talk about the extensive properties now. I'm just going back up. Let's just do it here. Extensive properties. So extensive properties are, they are dependent on amount or quantity of matter present. All right, and so examples of this could be your, things which depend on how much of it is there. So, you know, size, obviously, mass, length, weight, and so on. Many other examples, but those are the ones that come to mind. And then lastly, let's just talk about chemical properties and chemical changes, and then we should be done. So chemical. All right, so chemical properties are, well, the way you would define it is, let's just do one, chemical properties. So this basically is a little different from physical because it actually involves the composition of matter. So the way I would define it is that it's the potential to undergo chemical change by virtue of composition of matter. So the basically like the potential of matter to undergo change which affects its composition basically. And that may just sound really wordy, but I think examples again help explain that a little better. So examples of chemical properties could be the acidity of something. So you can only really measure that once you change the composition a little bit. Toxicity as well, even the flammability. you know, even solubility. And chemical change, which is the last little bit that we have to go through, that is the change of matter from one form into another. And this occurs through a chemical reaction. Occurs through chemical reaction. And so examples of this could be, well, if we were talking like daily examples, like things that you see day by day, you could say cooking an egg. You're fundamentally changing the matter. You can't undo that either. You could say burning something. So example could be burning wood. You could also say the rusting of iron. A bit more scientific there. Rusting of iron. And yeah, well, that's pretty much it. And so that's matter and its properties. That's the bare bone basics, I would say. Pretty easy stuff, but it builds a good base for you to work on for the rest of your course, you know. And yeah, that's about it.